we are here to make you score higher than you expected. Don't forget to subscribe and share this video. Please share this video. God bless you as you do so. So let's see those questions. We see the 40 JAMB questions here. I'll take it one after the other. So we have number 1. In a gas cylinder of fixed volume 12.75 dm cube, a pressure of 3.5 atm is exerted when the cylinder is completely filled at room temperature. A man was given excess money, $17, to fill the cylinder completely at the rate of $1.2 per dm cube of cooking gas. When he returned, the pressure of the cylinder at room temperature was found to be 2.75 atm. How much did he pay to the gas station? So this is all about having to relate the pressure and then the volume of a gas. So when the volume is actually, say, has a fixed volume and the pressure exerted, so it's all about using your discretion. When it is completely filled, the pressure should reach 3.45 atm. So which means we have to actually ascertain the level it was filled by the pressure that is there. So the man returned and it was found to be actually 2.7 atm. So maybe I take a screenshot and explain this. See what I mean here is that from the question, highlighter is necessary. Okay. From the question, they told us that it is the volume is 12.5. That is the volume. 12.75 dm cube. That's the entire volume, which corresponds to 3.45 atm. And then it was found to be this. So we can use this simple pairing to discover where the level is when the man returned. So whenever it is filled to the level of what? 3.45 atm is only when the molecules of gas there is up to 2.75. Therefore, one can simply say 12.75 atm is equivalent to what volume? By doing that, we can now do cross multiply and find the volume that the man bought. And from the volume the man bought, we know the cost of 1 dm cube. We can now multiply by the cost and know the amount remaining. Okay, so we move on to the solving page. I have to discard this. Okay, over here we are saying about I gotta divide the screen into 2 to help us. Okay, so 1, we just say that 3.45 atm is exerted by 12.75 dm cube. Then 2.75 atm will be exerted by what volume? That should be 3.45x is equal to, you cross multiply, is equal to 12.75 times 2.75, such that the x will now be 12.75 times 2.75 all divided by 3.45. So going to our calculator department, we have that from what we have there, we say 12.75, if I can remember well. Okay, they say 12.75 times 2.75, of course. Okay, 12.75 times 2.75 is giving us 35, then divided by 3.45. So divide by 3.45, which will give us 10.163. So it was filled to a volume of 10.163, And remember that the 1 dm cube is 1.2, so we can say 10.16 times 1.2, which will give you 12.192. So the man paid 12.195, that's $12.2 to the gas station. So that's on the approximate 12.2. So the answer to the question is exactly A, 12.2. So that should be 12.19, which is approximately 12.2. You know, it's easier than you think, but the way it was constructed is an applied question. You might go trying gas laws, all these things. Okay, now number 2 says, which of the following compounds is commonly used in car airbags? That's applied chemistry for you. Sodium sesquicarbonate, B. Sodium azide, yes. Sodium thiosulfate, potassium hydrogen tartrate. So the answer to this question is option B. So number 2 is option B, which is sodium azide. So that's sodium trinitride. Sodium azide, it is sensitive to shock. So sodium azide, when there is a car crash, it triggers it to detonate, releasing sodium, metal, and nitrogen gas. As you can see in this equation, though it is sensitive to hard shock. Not every shock will do that, but the limitation is that the car, I've seen some people that their car responded to a shock that is not for crash, maybe due to bad road over here in Nigeria, of course. It will actually, because sodium azide is a sodium trinitride, it will automatically release sodium metal, which is dangerous, and there is another reactant mixed up to absorb the sodium with the release of nitrogen gas. So to balance the equation, we need to put 2 under sodium azide, that's sodium trinitride, and then definitely put 3 here. So from this, one can see that a little amount of sodium azide can give you a lot of liters of nitrogen gas, which pops up to save the driver from hitting, or any other person sitting in front of the car from jamming the chest against anything. So the answer to that is sodium azide, and then that is a contained trinitride ion. So it's for safety. This is where chemistry is applied to save life. Any science that is not applied is a waste. But over here in Africa, we believe in writing and writing and writing. Okay, the next one is atoms of different, that's number 3. Atoms of different elements with the same mass numbers are called, this is called isobars. That is option A. So number 3 is option A, isobars. Isobars actually mean atoms of different elements with the same mass numbers, but you'll be tricked by isotopes because it's only isotopes that you know. Just take a look at this. When we use the word isotopes, they must have the same. What if you have an element, in this case there is 6, as you know, there is 6 here, but here is 12, here is 14, this is carbon. But in some situations we have elements that will have different, of course they are different elements, but this one is called them the same element because of what? Because they have the same atomic numbers, and it's atomic number that identifies the element and not actually the mass number. So if you have a situation whereby we now reverse it up there, maybe here is now 14, here is now 14, and here becomes 6, here becomes 7. So you can see that we call them what? Isobars. So these ones are referred to as isobars, while here is the isotopes. So isotopes share similar chemical properties, but isobars don't. They are different elements. Therefore, I'm supposed to represent this with Y to show that they are never of the same element. As you can see, this is going to be carbon and this is going to be nitrogen, and they are quite different. Okay, so the next question is number 4. During the calibration, I think I'll take a screenshot of this and solve gradually. Okay. Then number 4 says, during the calibration of from the ones we have answered so far, mark the answers. 2, then which of the following? Number 2 we said is sodium azide. Then number 3 say atoms of different elements. Since the atoms of different elements with the same mass number, we call them isobars. Then during the calibration of a plane measuring cylinder, it is plane. We have to note that. Like, this is going to asking us about how calibrations are done, meaning if we have something like this kind of measuring cylinder, but it's not yet calibrated. So you use water for calibration because the density of water is 1 gram per cm cube. That means if you bring your weighing balance and place this cylinder, measuring cylinder, on it and pour water, if you pour water, the mark that reads 1 gram, when this reads 1 gram, assuming the water level is here, and that means that this mark is the 1 cm cube, because at 4 degrees the density of water is 1 gram per cm cube. So the same thing is applicable. 2 grams will be 2 cm cube, 3 grams will be 3 cm cube, until the 10 grams mark. So you can use water, pure water, to calibrate your cylinder, taking a look at the density as this 4, 5, 6, 7. Remember, in your solubility, this is also why you can solve that 1000 grams of water is also equal to 1000 cm cube of water. So that's the explanation. So the answer to that is B, 10 grams of distilled water. The calibration at this, the 10 cm cube mark corresponds to that. That mercury is heavier, so the answer should be B. Calculate the molar mass of a gas V if 2.0 cm cube of V is 5.5 times as heavy as 8.0 cm cube of hydrogen gas at STP. Calculate the molar mass of a gas V if 2.0 cm cube of V is 5.5 times as heavy as 8.0 cm cube of hydrogen gas at STP. Okay, this we are going to use a vapor density here, the definition of vapor density, which says that vapor density is the number of times a given volume of a gas. Vapor density of a gas is defined as the number of times. Vapor density of a gas is the number of times a given volume of the gas is as heavy as the same volume of hydrogen gas. So hydrogen is our reference point. So this implies that hydrogen is the lightest gas and every other gas must be heavier than it. Now, how many times a gas is as heavy as that? The same volume of hydrogen represents the vapor density of that hydrogen. So that means for you to know the vapor density of an unknown gas, maybe V, you have to bring a known volume of that V. Maybe this is 3 cm cube. You also bring the same volume of hydrogen gas. This time around, this is hydrogen gas, 3 cm cube also. Place all in a weighing balance and know what they read. Hydrogen gas must be lighter because that's the lightest thing. Imagine what is 14.4 times lighter than air. So in this case, what we must do is hydrogen, let's assume it weighed, that 3 cm cube of it weighed maybe 0.1 gram. And over here, 3 cm cube of V now weighed 0.6 grams. What does this imply? It implies that the same volume of V
as that of hydrogen weighs 6 times more than hydrogen. Therefore, the vapor density of this gas is equal to how many times is it? Vapor density of V should be equal to the mass of that gas, of a given volume of that gas, all over the mass of the same volume of hydrogen, which is 0.6 all over 0.1, which will give you 6. Therefore, the vapor density of this gas V, is 6, because it is 6 times as heavy as hydrogen gas. Remember, the temperature and pressure of the hydrogen and that gas will be the same 10 for this to work out. Therefore, relating this to the question they asked us, if we relate this to the question they asked us, if I can remember, they say that 2.0 cm cube of gas V is 5.5 times, yes, as heavy as 8.0 cm cube of hydrogen. What do you notice here? There is a discrepancy from the definition. This is 2 and this is 8. Well, from what I explained here, I made it 3, and they say the same volume, a given volume, and the same volume. So your job to choose a specific volume, make sure that the same volume of hydrogen. So which means we can now ascertain how many times will 8 cm cube of V be as heavy as 8 cm cube of hydrogen. If 2.0 is 5 times as heavy, 8.0 will be what? Whatever 8.0 weigh as is the vapor density. Okay, so now we have to clean up. Remember, this is Her Majesty's World. Please subscribe and share this video. Please. I am here for your academic success. Now, let us see if 2.0 weighs 5.5 times, 8.0 will weigh how many times? So you cross multiply, you find out that 2x is equal to 8 times 5.5, such that x is now, to clean up for more solving space, you find out that x is now 8 times 5.5 divided by 2. So by so doing, we go to the calculator department. 8 times 5.5, okay, 8 times 5.5 is equals to 44, then divide by, how many over there, divide by 2, divided by 2, we have 22. So the vapor density of the gas is 22. That means equal volume, 8 cm cube of gas V is 22 times as heavy as 8 cm cube of hydrogen gas. Now, the question says, what is the molar mass? We now go back to relate that 2 times vapor density is equal to relative molecular mass. So the relative molecular mass of a gas is equal to 2 times vapor density, and they are asking us for the molar mass, which you can replace as the relative molecular mass. Therefore, the molar mass of the gas of V is equal to 2 times the vapor density, which takes us back to 44. So the answer to that question is 44 grams. So the vapor density is actually 44 grams. That is option B over here. Then number C says the laboratory apparatus used to support the receiving jar during the collection of gases over water is clay pot, no. Boss head, no. That one is for stand and clamp. Beehive shelf, yes. Tripod stand, yes. So you watch my video where I do use this beehive to support the cylinder as I collect gases and measure the volume involved. Still here at Her Majesty's World. We believe in practicals, and we show you what we teach. We don't just teach the theory, we do it practically. Okay, which of the following best explains why H2SO4 and HCl can never be obtained? As I think I have to clean the past solving. so that we can see where. Okay. Which of the following best explains why H2SO4 and HCl can never be obtained as solid crystals? Have you ever seen solid H2SO4? It doesn't exist. How about HCl? It doesn't exist. What I mean is you can see sodium chloride crystal, solid, you dissolve it in water, and heat evaporates, you get back the crystal again. But HCl can never be in solid. Some organic acids, such as ethane dioic acid, oxalic acid, that is another name. The common name for ethane dioic acid is oxalic acid, of course. You get the solid form of them, but you cannot see such in H2SO4 or HCl. Option A says because of is disproportionation in water. Disproportionation reaction is not a reason here. Remember this term, disproportionation reaction is just a reaction where one element is both oxidized and reduced in the same reaction, such as in the decomposition of hydrogen peroxide. This is not all about just answering this question, but explaining further to help you out. In the decomposition of hydrogen peroxide, H2O2, which decomposes naturally, that's spontaneously, but if you add manganese oxide, it becomes faster. In this reaction, you check that if you look at hydrogen here, hydrogen is not a problem. If you look at oxygen here, the oxidation number of oxygen in the hydrogen peroxide is -1. But the oxidation number of oxygen in water is -2. But the oxidation number of oxygen in a oxygen molecule is 0. So what can you conclude there? Just watch. The same oxygen here, -1, -2, and 0. So we all know that when you move from -1 to -2, that is reduction. That is decrease in oxidation number. But when you move from -1 to 0, there is increase in oxidation number. So oxygen is both reduced from the peroxide ion to just the oxide ion. The same oxygen is oxidized from the peroxide ion to oxygen gas. So you can call the decomposition of hydrogen peroxide disproportionation reaction. So it doesn't connect to the question number 7. So option A is off. Then B says forms azeotrophs with water. Yes, that's the correct answer. Azeotrophs are constant boiling mixtures. Two mixtures of two liquids that boils at constant composition, meaning you will heat them, water will go. At a stage, water cannot go without taking that molecule out. So at a certain concentration, it becomes impossible for you to know the difference between the vapor coming out from the solution of H2SO4 and HCl and the content remaining, such that the content of the vapor is the same thing as the content of the liquid remaining. To make it easier for you, if you heat concentrated HCl, the acid fume leaves. So if you need to produce HCl fast for your fountain experiment in the lab, you just bring a concentrated HCl and heat it. It liberates that gas HCl. When it liberates the gas HCl, it makes the solution more dilute, leaving the water behind. But when you heat the diluted one, it liberates water, leaving the HCl behind, making it more concentrated. But if you keep heating the diluted one at a certain concentration, at about 20.2% or 20.24% concentration, both the strength of the vapor and the strength of the solution behind remains the same. And in this case, we call it constant boiling mixture, such that what comes out of the solution as you heat it is not water, neither is it HCl, but two of them. So it becomes difficult to evaporate them to dryness. So the answer to the question is B. They form what? Azeotrophs. That is what we call constant boiling mixture. Okay. So now the next one is number 8. Neutron number is 0 in the nucleus of A. Proton, D. Deuterium, C. Diamond, and then D. Tritium or Tritium. So looking at this is simple. The answer is proton because proton lacks a neutron in the nucleus. So Option A is the correct answer. The two possible isotopes, the two common naturally occurring isotopes of hydrogen should be deuterium and protium. Tritium can be artificially made, where protium dominates about 96 and above percent in the sample of water, or in the sample of hydrogen available is the protium, and is denoted like this: H11. Deuterium, which forms an oxide called heavy water, and then this last one, this is the tritium. So if you know that proton number is gotten by minusing the, if you want to know the proton number in a sample, proton number is just the atomic number, which is denoted below when we write a nuclide. Then, but neutron number is what I intend to say actually. So neutron number should be equal to, you subtract proton number from mass number, that's mass number minus atomic number. So when we have this element H11, we discover that the number of neutron is equal to 1 minus 1, which is 0. But in this case, H21, which is called deuterium, when you do the same mathematics, you have that is 2 minus 1, which is 1 neutron. For the tritium, which is the only radioactive among these three, tritium is the radioactive isotope of hydrogen. It has 2 neutrons, and that makes it unstable. When you have more neutrons far than the proton in your nucleus, you will likely be extremely radioactive, of course. So this is the stability of nucleus playing a role in the ability of an atom to be radioactive. Now we go back to the next question. Question number 9. Which of the following practices will help control global warming? A. Burning of fuel. B. Increased forestation. C. Increased use of automobile engines. D. Recycle every waste by burning them down completely. Looking at all this, global warming will control it by whatever that will reduce the release of carbon dioxide or carbon into the atmosphere. What will remove it entirely, and that is increased forestation. Option B. Increased forestation, we do that by increasing the rate at which the plant takes in water. So, the rate at which the plant absorbs carbon dioxide, because during photosynthesis, carbon dioxide is used as a raw material. So that is why plants can help to refresh the air. You are encouraged to plant trees more to make the air fresh, because the plant will remove the CO2 which we breathe out and purify the air for you. Now, number 10 is a calculation, and it says if the cost of 1 mole of electron is 62, calculate the cost of producing 54 grams of aluminium through the electrolysis of molten alumina. They told us that aluminium is 27. So we go to our solving sheet, having the question in mind that the cost of 1 mole of electron, 1 mole of electron costs $62. Then what will be the cost of producing 54 grams of aluminium? Now, looking at this, first of all, we have to write the half cell equation taking place at the cathode during the electrolysis of alumina, which is Al3 plus 3 moles of electron to give us Al. This implies that 3 moles of electron will discharge 27 grams of aluminium, because 27 is the molar mass of aluminium, meaning 1 mole of aluminium will have automatically 27 grams when you want to weigh it. Now, by me looking at this, it's already established that that the 1 mole of electron is costing 62. But before then, they gave us 54 grams. Yes, if 27 will be discharged by 3 moles, 54 grams will be discharged by X, which will be automatically 6 but let's do the religious way. You cross multiply, it becomes 27x is equal to what? 54 times 3, such that x will divide both sides by 27. That's the coefficient of x. Cancel, cancel. X alone is equal to 54 times 3 divided by 27. 54 times 3 divided by 27, which will give you 6. So 6 moles of electron is required to discharge 54 to produce 54 grams, and they have already told us that 1 mole of electron will cost $62. Therefore 6 moles of electron will cost x, which is automatically 62 times 6. From the calculator department will give us 62 times 6 is 372. So $372, which is huge money. Remember, this is just theoretical questions. That's not applicable because this is too expensive. So we go back to the question and see that from our calculation, option A have it correct. So option A have it as 372. If you're not careful, you will get option D, which is 124. Okay. The electronic configuration of scandium atom is, they show us the distribution of the electrons in the shells of scandium. Scandium is number 21 as indicated there. The scandium itself is number 21 as indicated here. So being the number 21, we are distributing 21 electron, and you look at the whole option. The options are arranged in such manner that they will all give you 21. 2 plus 8 is 10, plus 7, 17, plus 4, 21. B, 2 plus 8, 10, 8 plus this will still give you 21. All the options landed in 21. So which one do you think is correct? So this is all about the uniqueness of the transition elements. So as usual, after or before scandium is calcium. So calcium is number 20. So for instance, 20, and we have a K, L, M, N. If normal, before that we have 2, 8, 8, 2, which implies that the one following it, which should be scandium, right? Scandium now is 21. So following this pattern, 2, 8, 8, it remains now 3. You put it here, but this is wrong. This is the unique nature of transition elements. Transition elements, in their configuration, the electrons are added in the penultimate shell and not in the outermost shell. What I mean is second to the last shell. And the second to last shell here is the M shell. The M shell is the second to the last shell. Therefore, if there is any from scandium, titanium, if extra electrons are added, they will not be added here, they will be added here. And that makes it unusual for transition elements. So the question might look simple, but unfortunately difficult. So the correct thing should be 2, 8, 8, 2. Extra electron being added will automatically enter in the M shell, the second to the last shell. So it's going to be 2, 8, 9, 2. This is the correct configuration of scandium. So when we go back to the question, that rhymes with option. The exact option there is option C. I know you'll be tempted to answer option B, but unfortunately you're wrong. So this is what this question is meant to do for you. Let's show you the rest of the questions. We'll handle the answers to the other questions, explaining them in details when I will go live for this year JAMB. Remember, you should tune in, join us, and ask your questions. It will be better to display the answers and the explanations live, where you are also allowed to come with your own questions. This is my own contribution to ensure your own academic success.